Okay, hello everyone. Oh, is my mic on? Okay, yes. Hello everyone, this is the coding tutorial, Bits and Bytes, for Unity. Now this is the third tutorial and you've probably been waiting for this most demanded tutorial out of all of them, as shown by statistics during launch night. 70% of people wanted to learn Unity, and here it is. So first of all, I'll go through the windows of the stream. So this is the tutorial slides window, as you can see here. And then I'll switch over to another one using OBS to the game, and the Unity editor, and the Visual Studio editor. Okay, so now going back to the slides. As a reminder, Unity version 2018.1.2 F1 for tutorials, same as from before lockdown. And we'll go through 5 different things. Visual Studio, because I'm sure there's some of you who haven't installed Visual Studio, so we'll go through that. Variable types, fundamentals of programming. Every variable has a type. Third topic, conditionals, checking for logic, if statements, loops, stuff like that. Fourth, and this is where we really start to get off script and into the demo side of things, functions, where we show how you actually input functions and get them to work in Unity. And for our fifth topic is an example of problem solving. It'll be pretty open-ended, this topic. Don't know if it'll take the rest of the tutorial, takes like half an hour, or take like 10 hours, in which case I'll just leave the rest up to the more skilled coders to handle as an extra challenge. Okay, so for Visual Studio, please don't use Notepad unless truly desperate. That is very important. If you're trying to code using Notepad, you must be in a hell of a rush. Alright, so I'll go through how to install Visual Studio. So since we're using 2018.1.2, we'd want to use Visual Studio 2017. If we use 2019, it'll be too out of date and it'll cause some weird as bugs most likely. So the slides will cover how you install Visual Studio, assuming you already have Unity 2018.1.2 F1, as well as Unity Hub. Alright, so the second way is through directly Microsoft site, which I'll click into. You'll need to download here. And you need to log in with an email. If you have your own Microsoft account, you use that. If you have university, you can also use that university email, or you can make a throwaway one. And if you haven't installed Unity, do so now through this link over here in the slides. Oh, I repeat again, these slides are in the Google Drive, the resource drive, underneath semester 1 tutorial 3. Okay, so installing Visual Studio 2017. This screen is probably familiar. You just go to the Install tab, click on these 3 red dots, 3 gray dots on the top right of the correct version, and you click Add Modules. Now, Unity Hub takes 2 gigabytes, despite what it says when you click Visual Studio Community. Now, there's going to be like, for me it was like a 15-minute wait time when I installed it. So if you're installing this now, you probably want to pause the stream and wait until it finishes, and then get back onto the stream at a later time. Or you could, stay and listen, I guess. Now back from those 10 minutes, assume if you've just went out for a pause and downloaded Visual Studio, you probably would have had these 3 windows pop up. Don't have an account, you could ignore that or sign in if you already have one. select C# for development settings, and of course dark is the superior color, so always choose this. Never go for this, always choose this. And there's the Windows firewall. Now to actually connect Unity to open Visual Studio, you click on Edit in the top left of Unity, Preferences, External Tools tab, and then set the external script editor to Visual Studio 2017. It's pretty self-explanatory. That means that whenever you double click a script file, you will now open up Visual Studio instead of, I don't know, Notepad or your previous coding environment if you've got it. And that was it. Well, easy, wasn't it? Now I'll show an example of Visual Studio straight after this slide. So on the bottom left you see here solution. Yeah, this example of a project that we did for our tutorial, this tutorial. And you'll see a Solution Explorer on the left side. Now I would have changed, you probably would have changed your windows later on as you code more and more to suit yourself, or your display configuration, whether you have two monitors or not, stuff like that. The Solution Explorer shows all the files in their project. On the bottom right here, you have code auto-completion. That means that whenever you start typing a function, it drops down a menu showing the list of potential matched function names. You can use this to tab, and then it'll autocomplete for you. The more you use coding, the more smarter it gets, so it recognizes that you use certain functions more than others. For example, I use debug a lot, so typing in DE instantly fills it up with debug.log. Oh, or debug anyways. Just press tab and it'll autocomplete it, as I'll show you later on. Now onto the Visual Studio editor. Okay, this is, oh, hold up. Okay, this is the Visual Studio editor. Oh, showing up a bit big. Let me just rearrange the window here so it fits. Okay. So as you can tell, all of my tabs are hidden to the sides. That's because I usually put the Visual Studio editor and Unity editor side by side. Therefore, I need as much space as possible to see code. So usually this would be in the top, but I pinned it down to the left side. Solution Explorer, as I mentioned, this used to be on the left. Now I moved it to the right. So whenever I refer to Solution Explorer in this stream, or any of my future streams, it will be on the right side. As you can see, I'm right now in the learning.cs file as shown by this tab up here. There's also where is it? Okay, here it is, the errors list. Now this comes default in the bottom side. If there's a compile error, you'll see it here. Okay, now back to the slides. Onto the variables. After this section, I'll get straight into the demo, and I'll show you work examples of how to do variable types in C# and Unity. Now, if you've seen already, there's already another PowerPoint. This PowerPoint I'm in right now is called Bits and Bytes. Okay, so this is the tutorial drive. There's 4 files, so you should download all of them. This is the one that I was just looking at right now, the slides. This is the slides from last year, which goes into a lot more detail. Since I'm doing a stream, I will be sticking to this slide. This is the game. If you extract this, if you download and extract it into your folders, you could play the game. That I'll show later on as well. And this is the repo.it files that you could use to make a fork and do some of more problems mentioned in the other PowerPoint as well. Alright, so in that other PowerPoint, there's more context about C#, more details about concepts I'll be streaming today, because I won't be able to cover all of them in time, some example codes, and a repo.it exercise, which is updated for this year. So in case you're not certain, repo is a good learning site. Just follow the link shown in the other PowerPoint, and then you'll be able to have a very nice 1 to 2 hour exercise in C# Unity. Yeah. The other PowerPoint also contains some official documentation, like the C# tutorial by Microsoft themselves, as well as the Unity scripting API. For this stream, however, I'll just show you the ropes and what it looks like and actual coding. Okay, so variable types. Variables are to scripts, like words are to articles. Variable types are to variables, like nouns, verbs, adjectives are to words. You must declare variables before using them, or else you'll come up with lots of annoying, pesky errors. They also help you code better, because if you try to assign a variable of a wrong type to another variable, if you assign a variable of a wrong type to a variable, say int, and you try to assign a float to it, then it'll come up with errors like, as I mentioned below here, missing wrong type conversion. And that's a big no-no in terms of the compiler. By keeping everything the same type as how you declared them, you can understand how code flows more easier. And right here is an example of a int declaration. Ignore the private. Int numTurns equals 1. Integers are whole numbers. Now for floats, they include decimal places. Boolean, they're simple true and false statements, sort of like how bits can only be 1 or 0. And for string, the classic starting example of coding, hello world, basically just normal characters. I could go into a bit more detail about how strings are just a series of integers represented as characters, but that's for another day. Now I'll quickly scoot over to Visual Studio. Okay. So here is this example test script I did. In it, you'll find a couple of questions. I'll go through them now. So this is task 2. Task 1 was installing Visual Studio itself, of course. Now task 2 is slightly harder. If you're completely fresh to coding, these will be very helpful for you to learn. Of course, if you're already a skilled programmer or you've moved from another language, I suggest you skip forward to the end of this stream so that you can have a bit more complicated tasks for your liking. I'll also mention a bit about more complex topics near the very end of the stream. Okay, so back to the beginners. This is a pretty basic problem. Task 2A, question 1. How many cards are in a deck, excluding jokers? Pretty simple. I won't say the answers. I'll do it after I announce all the questions. But question 2. What is the chance of flipping 10 heads in a row? Okay, that's 0.5 chance of flipping 1 head, but what about flipping 10 heads? Now assign it to if. Also, I've written here common coding mistakes in case you've want to double check what I mentioned earlier. Or not mentioned earlier, what I mentioned in the future after I do all these questions. Task 2B for Boolean, make a b equal to true without writing true. Seems interesting. We'll go over that in a couple of minutes. And of course the classic programming question, make the scene say hello world. Excluding the inverted commas, of course. You see that I've already set default values for some objects, not all of them really. Because if you don't, you get a couple of errors, which I'll mention later. For the second part of task 2C, now make the console say too, using debug.log. Okay, now time to go into the game and actually see the Unity editor for the first time. Okay, so this is the view of the Unity editor. Let me just rearrange a couple of windows. Oh. Okay. So this here is currently in the gameplay scene, but you'd want to stick to the learning scene because this is where we start learning. Now I'll repeat from what we mentioned in the first tutorial. The left side is the hierarchy tab. This is where you have your game objects. On the right side, the inspector tab. And on the bottom side, you have the project and the console tab, which that wasn't mentioned earlier in the first launch night tutorial, but I will go into a lot more detail here. As you can see, there already appears to be some warnings and some info messages too. So let's see what happens when I play this scene. Oh, there's already a no error. We'll just ignore that for a second. Okay, so as you can see, there's 3 buttons over here and a quit button. And there's 4 objects being shown here. First of all, it's 42, 3.142. Noughts and crosses overlapped on top of each other, and a string, press play. Now, if I press each of the buttons, oh, nothing happens, of course, because there's nothing in the functions yet. And of course, because there's no reference exception. Alright, so if I go back out, and I go back into the visual editor, I've rearranged the window here. You might not be able to see this, but I've actually have them side by side on my computer. It makes it way easier to code if your Visual Studio is seeable on the same display as Unity Editor. Now I'm going to click play on the Unity Editor and see what those bugs are right now. Hold up, let me just debug a little bit. Excuse me for a second here. Feel free to take a 2-minute break while you mess around with Visual Studio and the Unity files. Okay, sorry for technical issues there. So actually, since we're on the oops, wrong screen. Okay, since we happen to be on Unity right now, let me just go into how you connect Visual Studio to Unity. Now, the menu doesn't show up. Hold up, give me a second. Okay, so as you can see, I have Visual Studio on the left side and game window on the right side. And if by clicking edit here, preferences, oops, you get to external tools, Visual Studio 2017. Now I usually use code, but for this tutorial I'll stick to 2017 Community Edition. So you click that, and voila. Voila. Clicking on a script opens it in Visual Studio. Alright. So this here's the int and float and conversion. I'll stay in the display window from now on. Probably easier to teach with. So this here's how you declare int, or how you declare any variable really. You do it this way. Assuming you ignore the square brackets, so that will be the type, and then variable name. Oh, that autocorrect equals value. In fact, not just any value, initial value. And then you always end it with a semicolon. That's the typical way you initiate a variable. So how many cards in a deck excluding jokers? Well, 52 of course. Now I'll give an example of assignment. I equals 52. This means that you assign 52 to the variable I. And as you see down here, it assigns it to a result. Now, if you this is a slightly tougher problem. Flipping 10 heads in a row. Now you need to look into how exactly does C# do math functions like to the power of. You could try this. That's what one would usually try if they haven't tried programming before. Let's try f equals 0.5 to the power of 10. Flip a coin heads 10 times in a row. 0.5 to the power of 10. Ah, what's this? A red squiggly line. Operator to power of cannot be applied to operands of type double and int. Okay, that means that whatever you're working with has to be in the same type in the operation. So 0.5, as I mentioned earlier in the slides, that's a decimal value, so therefore it becomes a float. But 10 is seen as an integer, so we want to fix that to both of them to float, because we're assigning it to a f, which is a float. You do conversion by typing the type enclosed by round brackets. Okay, now it comes up with another error. You know for sure now that it's not due to type conversion, but it's something else. Remove unnecessary cost. Okay, that is not helpful at all. But in this case, the answer is simply that there is no such thing as a power operator in C#. You have to use a function. Now, I'll explain what functions mean in more detail later, but basically, they allow you to perform something on a variable. In this case, you want to give the power of 0.5 to the 10th power. So in fact, I'll skip a lot of searching later. I'll just tell you the function straight up. It's mathif. That's the math function. In it, you'll find all the math functions relevant for games, for example, physics. Use mathif a lot. And there's also other very useful functions in here as well. So using autocorrect, you could scroll down and see all the relevant math functions you need. In this case, we want power, so that starts with P. Oh, this is pretty handy. Returns f raised to the power P. Okay, remember those. Remember that pop-up on the right side here. You'll need it. Float if, float P. Means you need to input two floats. and it returns a float, which is exactly what we want to put into if. So we'll just fill that up.
Yep, here it is.
0.5. To power 10 for 10 heads, and we want to convert this to float. And as always, semicolon. Okay, now this should work. Okay, I'll do the rest and then I'll try it out on a test script later. I'll finish out the rest of these problems first. So make b equal to true without writing true. Well, you know that Boolean only has two values, false and true. Now there must be it would be pretty handy if there was an operator that sort of inverts the value of a Boolean, right? Well, it just so happens that there is. The exclamation mark. Now you can actually assign variables into itself. So it first does this operation and then assigns it to itself. This way you flip around the value of b, so it turns from false to true. Now that's a pretty simple one. There's many other operators in here. I suggest you look up the operators section under C# documents. Now for the last one. Alright, so this here's the basic. In here is code text here. Okay, we want to put in hello world in there. So we'll do that using string equals hello world. But then you notice that the name hello does not exist in the current context. That means that it thinks these things are variables, but they're not. We want them to be strings. And as you can see from here, we have to add these double inverted commas, much like quotes in articles and stuff like that. Now, this would correctly return string hello world to the function. Now we have to try making the console say hello world using debug.log. Okay, so debug.log lets you output strings to console, and that's actually really helpful. As you can tell from the debug, it's used for debugging. A bug is an error in a program. If you want to remove all the errors in your program, you'd use lots of debug.log as well as other debugging tools to remove bugs in your code. A simple script will have few, but say you're making a pretty huge game, then you'll have lots of potential bugs that you need to fix using debug.log. Now I'll show an example of autocorrection being very useful here. So if I type in DE only, it comes up with the script, and then debug. As you can see here, it says logs message to Unity console. Takes an object message, usually a string, and then outputs void. Now, void is nothing, as you would expect, so you don't have to return anything. That's why most messages of debug.log doesn't assign to anything. Just put in the string here, and end of a semicolon. Ignore these warnings. Okay, let's try it. I'm actually kind of nervous if it'll work or not. Well, what do you know? In fact, it seems to be generating a lot. There's probably a function in here updating it every frame of the second. But yes, good to know that works. And look, what's this? Ah, okay. I see what's the issue here. Hold up. Let me just switch to a black screen for a couple of minutes. Sorry. Okay, apologies for that. It appears that I've had discussion that's probably a better idea to go through the REPL link to better learn and to better learn simple things like this. So I'll just have a sig over to that in a second. Okay. So using the, sorry for the cut, from Visual Studio here, but this is probably a better way of teaching you guys simple variable types, conditionals, and loops. So as I'll show you the tutorial slides that mention how to actually use REPL. So if you go to this link over here, and you should come up with this screen. Now, you should fork immediately without changing any of this. This opens up a duplicate that you own, and it'll change the URL, so you're not actually editing the shared URL over here. Now, these are 6 different files, which is shown here. On the left side, you have the file explorer. On the right side, you see the compiler output. As you can see, you don't have to worry about Unity using stuff here. So this is a great way of learning. Now, as I repeat before, if you're a skilled programmer or you came from another language already, I suggest you skip to the end of this tutorial, as that contains more complex concepts to learn. Okay, back to this example. So here, you see 4 examples: string example, bool example, int example, float example. As you can see here, it's uncommented to type examples. If I press run, everything compiles. Now, the first time things compile, it takes slightly longer than usual. And you can see, hello world. I apologize for the cut earlier, but the problem is, for string at least, is the same. For other ones, it's kind of like, it's different, but the concepts are still the same, so don't worry about it. Okay, so to change the examples, you uncomment and comment out lines. So if you want to get an example of Boolean, Booleans are true and false, as I've mentioned earlier. Look over here. Oop. Where is it? Okay, Boolean example. Ah, I should start from the top, shouldn't I? Int. Okay, so this is an example of an int. As I mentioned before, you declare any integer with the 3-letter int, the variable name, and in this case there's 3 variables that we all want to equal 0. Not sure if this works in Unity, but for REPL it definitely does. Time for some simple math. Yep. A to B, A times B, result times B, times 2. Result plus plus. This is the incremental operator, which increases things by just 1. And then there's an interesting case, division of B divided by A, which, as you see, has some special properties for integers. Okay, so as you can see here, int example, result a plus b equals 5, as you expect. A times b equals 6. Now, the only one you probably weren't expecting is b divided by a. What happens if you divide 3 over 2? You might think, oh, well, 1.5. But, as I mentioned earlier, integers are whole numbers, which means that they can only take 1, 2, 3, 4, 5, and so on and so forth. Now, dividing by integers means that you ignore the remainder, and you only count the full divisions of the divisor from the denominator. Divisor from the numerator. So just like a fraction, b would be the numerator and a would be a denominator. Now, since you can only put in 1, 2 inside of 3 with 1 left over, b divided by a equals 1. Hence this. The remainder 1 gets thrown away. This just goes to show that you should never ever use integers or fractions, because that might lead to some big headaches. You use float for that instead. Now, to go over the float example, you can just have a read of this. Okay, in Unity, you don't use doubles, which is pretty common in other languages and other programs. We use floats for Unity, however. Floats gives a bigger range of values, and there's many other differences. But I'll get into that probably another day. Alright, so as you've seen before, assigning fractions into int results in error. What also results in error is if you try assigning a simple decimal to a variable into a float. But the thing is, you can't assign a decimal into a float without first appending if. This tells the compiler that, or the thing executing the code, the compiler, that this is a float that we want to assign into the variable. Without it, the compiler will complain about, oh, you're changing decimal to float. Conversion error. That's not cool. So always remember to add an if. Okay, so I'll play the float example right now. Okay, so you see here, integer I equals 1. Yep. db 1.2000 blah 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 1. And float. Huh? This isn't exactly the same. Why is that? Well, it's because floats are imprecise. And by imprecise, I mean that when a computer does lots of calculations, it deals with like hundreds and thousands of bits at the same time. And without there's this thing called machine precision error, also called epsilon, which means that if you do calculations that are too tiny, the computer might, I don't know, assign a very slightly different value to it, or rounds it up and rounds it in the case of this float. Now this is epsilon is very, very small, so you usually don't need to worry about it, but it just means that you shouldn't avoid working with numbers that are huge different in scale. Now, as I mentioned earlier, you could convert doubles to floats, and floats to doubles, and ints to doubles, and doubles to ints, etc., etc. You'll find that difference is also lost if you convert dB to float. As you can see here, what used to be 1.2000 is now 1.2. All of this is just to show that floats don't work in a large range of scales with floats. Basically keep it within like 3 orders of magnitude, so 1000 difference, or else there might be a bit of issues appearing. Now down here I talk a bit about type conversion and how everything has to be the same type when you're operating on them. Now integers are actually very useful despite not having decimals. For example, the simple fact that they don't have precision error means you could use them as counters, because the strange thing, as I mentioned earlier, 1.2 and 1.20001 they're not exactly the same. So if you try to compare them, you end up with some confusing errors, but that's because you're using floats when you should be using integers. Down here, converting to ints actually rounds down the values. You could use that property very nicely. Say if you wanted to round down the number of, I don't know, pizza slices one could have. You can't have 2.5 pizzas, that would be kind of disgusting. So you have 2 pizzas. Okay, for division, it's as you expect. With floats, everything makes sense. Yeah. This is with integers, 1 to 1. And with floats, 1.5. Okay, now that that's types done, we move on to conditionals. In this case, the if statement. I'll go through the case switch another time. Oh, by the way, this is the questions exercises, so you can do these in your own time. Just type in your code here, and then we'll test if your code is correct or not. But I'll skip here to the conditionals now. This is the example of an if example. As the name is correctly says, it's an example of an if statement. Wow, that's offensive. I should redo NCA level 1? How dare they? Okay, let's see here. There's a guess. It's equal to the string EX in caps. Okay. It says that I should type in exam. What happens if I do that? Down here it says if exam, console right line, simple. Okay, so if guess equals exam, then we do whatever is listed in between these 2 curly brackets. That's a simple concept of the if statement. It compares something to another, and if true, does that thing between the curly brackets. Down here, else if extends it so that you have multiple like if statements in a row, and only one of them could activate at a time. Say if I guessed exam in caps, what happens? Stop shouting. Oof. Fine then. Okay, so it goes in here. It misses this because as I'll tell you later on, coding is a very, very precise language. Typos, they will screw you over. So always be exact when typing in code. It bypasses the initial check, goes into the else if, correctly matches this Boolean operator, or statement, I mean. This results in true, because guess equals exam. Therefore printing this line. Now you see these two operators, as I mentioned down here, it's an OR operator. So it means if either of these are true, then it prints this statement. Yep. Now, let's see, what happens if I were to try getting this statement? As expected, it comes up here. But what happens if I want to go to here? If I type in exam, we already tried that though. It comes up with this. So how exactly does one get to this Easter egg console write line? Well, the simple fact is you can't. It's a repeat statement. And if it's repeated, it'll just do the first one first. And it'll either do the first one or skip over it entirely. So this is essentially useless code right here. It does absolutely nothing. And that's why it's called an Easter egg. Huh. If there's anything else, like the aforementioned EX, it misses all of these statements because none of them are true, and then it goes to else, which catches every other call. Hence the redo NCA level 1. Now let's try, actually no, the switch case example is, it's pretty basic, it's actually kind of repetitive, but there's no examples in the code that the tutorial game gives you. So we will skip straight over to loops. Okay, comment this out. Now let's see here, an array example. Now there's not many arrays in the game, the tutorial game, so I'll just go give a brief overview of the arrays. So this is an int array. It basically means that there's a series of integers. And that's it. That's what arrays are, a series of something. In C# you have to declare the size. Arrays have a special declaration method. You use equals new, the same type as before, and a size. You have to have a set size. Here's another type of object that's kind of similar to arrays called lists, but I won't go over them in this tutorial. So now we have an array that's 5 spaces big. Getting values from array called indexing starts with the first array value at position 0. Very important. Array start at 0, not 1. Assignment is very similar to assigning in normal variables, only that you repeat the name, but you only change the index number. And here, 2 times 2 dot string gives 9. So what's 2 times 2? 4. Gives 9. Okay, you can perform operations inside the index as well. So if I were to, for example, comment this out, 2 minus 1, that equals 1, so return 3. And what do you know? Oops, shouldn't comment this out after all. Okay. Yep, so indexes, accesses index 1, 2 minus 1 equals 1. And as you can see, we have assigned it 3 here earlier. Okay, this is array indexing and arrays in general. With arrays, you can have many, many different things put into one nice series variable of type array, or int array, or another type. Could be string array, could be float array, could be game object array. In Unity, it's a bit more involved than this, but you'll see in the tutorial game, or actually there's probably previous tutorials that we've done that use arrays a lot. So if you have time, you could go check them out. Arrays are also very good for iterating, and by that I mean doing the same operation over many different variables in the same array. So yeah, in the while example, see what this says. Oh, it seems to be taking its time. It's casually loading. I'll play it again. Now, as this giant string of numbers that represents the actual time. So you don't know it, but let's see. What is the time now? Hold on, let me check my phone. It is 7:06 of 30th April 2020, and that represents this number. Yes, it may not seem like it, but this is the current time since, I believe, some arbitrary number that the developers of this language set. So probably like 1900 or like 1990 or something weird like that. Now let's get into the code. This is a variable type you haven't seen before. We don't really use it much in Unity, so you could just, the only thing you need to know is a different type of integer that suits big integers. You don't need to worry about it in Unity, but for repo you do need it, or else you'll overflow, which is a concept I won't discuss today. Okay, so here is the while loop. While I is smaller than or equal to 5, what's this? Sleep. Okay, I guess half second. So this must be in millisecond units. Alright, so the compiler sleeps for 0.5 seconds, and then increases I by 1, assigns the current time to millisecond, and then outputs the value of I to string, because integers can't be displayed in the console without converting to string first, and then milliseconds to string, same thing, and then writes all the values one last time. So what happens is it goes through the loops 5 times. So I equals 0, goes again, this time due to this, I plus 1. Now I actually have a site prepared for this. Boop 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 boop. About infinite loops. If this I++ wasn't here, this would go on forever and probably crash your computer. You could try that for yourself, but well, not crash the computer, maybe, but it'll definitely freeze Chrome, unless this code is smart enough to realize that it's freezing. I won't try it now, but you can try in your own time. Just save first. So, infinite loops. If there's an infinite loop in Unity, what happens is Unity will actually freeze up. So all of your unsaved work will be completely gone. Poof. You have to restart Unity. While loops and the other type of loops, for loops, are notorious for this kind of thing, so do watch out for them. Now, onto the for loop example. Oh, actually, you know what? I'll try changing this to 9, and let's see what happens. What do you know? Increases it to 10. So just changing the single variable means it runs through an extra 3 loops. Oh, 2 loops. Wait, oops, it was 5 before. So 4 loops, yeah. comment this out. Onto the full example. Ah, this is a lot shorter than the other one. Yep, the modulo operator, as you remember from the type example, divides integers. But in Unity, they also work for floats too. And this here's the list of operators if you ever wanted to find out. Now here, you may be a bit confused as to the order of the operations, i.e. what happens first. Well, as I mentioned here, math is done first before logic, so I modulo 2, and we check if it's equal to 0, and then finally we assign this result into is even. Now this for loop goes from here all the way to here. It starts at I equals 0, which we've declared here, and for as long as I is smaller than 9, it runs through here, and then after each loop it does I++. Now there's another if statement. Now if statements should probably be becoming second nature by now. If is even, console write line is even, else is odd. 0, even, yep. 2, even, yep. Blah blah blah, seems right to me. What if I change this to 12 and I equals 2? What happens? Well, it starts at 2. So this, for for statements, the first phrase is the initial statement for I. This is the ending condition, and I++ is the iteration change. So every loop it does this thing, in this case I++. This is the typical way you see for loops being used. The same three variables is changed in each case, or checked. Alright, and that is the for loop. That's the loop examples. So you can test the questions on your own time. These are a bit more complex than the type questions. Yeah. Okay, now another 5-minute break for you to have a look into those questions, and then I'll go back into the slides about common mistakes that people do when they're using Unity. Okay, now back onto the Unity and editor. I've managed to flip a switch, embarrassingly. It was so obvious in hindsight. But yeah, back onto that question that we did earlier about the jokers and flipping 10 heads in a row. That repo exercise you could do at home after this tutorial or in the weekend. So yeah, I managed to get this bug debugged. Alright, so what happens now is press play. Now here, as we mentioned earlier, 52, math power float. Okay, so this is what's supposed to happen. What you should be doing is in line 205, just comment out this mumbo jumbo, and then just type in comment out this stuff, and then just put in return false here. That way you could test out the initial tests. This is just testing types. So like I've just mentioned earlier, or I basically already told you how to do everything for types. This function over here, make int float, returns type int float. What is int float? It's a structure. Now structures are used in C# to pass a bunch of data at once by creating a custom variable type. Therefore, the struct in this case contains a int and a float. So yeah, by assigning I and f to these two, returns a result, and it comes up and puts these two values out here, 52 and 0.000976565. Okay, b equals not b. Ah, right, this two needs to be. Hold up, let me just stick this in here. Okay, that's more like it. So b equals not b. Oh. Okay, we'll just ignore this for now. But yeah, not b turns us to false, so it turns it to true. Okay, so that's correct. Now for the last thing. Okay, that is strange. Just give me a second. Okay, I know, there's some funky business going on here. But as we mentioned earlier, hello world. Yep. No, it's playing when I press the middle button, but yes, this is definitely working. Okay, on to the next set of tasks, which is the conditionals. Now, I've already showed you how to do it, but basically these three questions over here, task 3A, 3B, and 3C, for loops. So I'll just make this return true. Okay, now I'll do a quick do-over of which one seems to be the hardest of these. This is if statement. Let's do this one. This seems pretty hard. Okay, so the problem here is use a while loop. This example here. Once again, I iterate. Infinite loops are very, very annoying to deal with. Make sure that it always this the condition that gets checked always terminates, or else your Unity will freeze. So here I go. While power is goes up to 7. So while power is smaller than or equal to 7, math dot 7 power. Okay, so this returns the thing we need to add on to I. So we need to attach this to I somehow. So I'll stick I equals but that'll just assign it. Oh, what's the 0? Okay, this needs to be a float, converted to int. Okay, this assigns it. But then we also want to make sure that the while loop actually terminates. So what we do is power plus plus. And at the end of it all, we'll just debug.log to show the value. missing a semicolon there. Okay, I suspect they'll probably spam this debug.log many times, but let's see what happens. Oh, what's this value? 8.23543. I wonder if this is correct. Oh, let me just bring up my good old calculator there. Actually, no. You know what? I'll use my 7 plus 7 to the... Yep, this is going to take quite a while, so bear with me for a second here. That seems definitely a bit different from this value over here. Now, I think I know why. It's because we're assigning it, but we should actually be adding it onto each other. So we'll have I plus equals int. Now, in case you're worrying, plus equals simply means I equals I plus this thing. This is just a shorthand, and it makes your code shorter and nicer to look at. So now let's see what happens. Oh, what do you know? Seems pretty close. Ah, there's a difference of 7. Oh, that explains why. It's missing the initial value, so it's missing the first 7. I plus equals 7. What do you know? Okay, this is the answer. Okay, so now that that's done, we'll move on to the actual... We'll move on to task 4, which I mentioned in the slides. Where is it? Additions. We go to dot notations and functions. It'll probably be better if I move these couple of slides down there, which I'll do so shortly. But basically, as I mentioned before, unlike C++ and C#, you call functions like this. So for all of you skilled programmers, you could tune back in, because this is the difference between C# and C++. The main difference is it uses Java-like dot notation. So you get these super long strings like this, whereas in C++ you probably would have like delegated it into a function or done some other things. I know it's been ages since I've used C++, but yeah, it's different. This looks complicated, but basically, this hit collider, this is a variable. It's of type 2D collider, I believe, 0.2D collider, but that's not the point here. The point is, it's just a variable. We access it, and then we use the dot game object. So we get the game object which holds A. In this case, A is a specific hit collider. Now, by specific hit collider, I mean an instance, a scene instance of a variable hit collider. That means it's not a type or anything. Although it has a type 0.2D collider, it is an instance of a 0.2D collider called hit collider. So instead of a specific, I would say in more technical terms, it is an instance of a 0.2D collider, or whatever type this hit collider is, and it's called hit collider. Okay, now we get the dot game object. All components have or are attached to a game object, and using dot game object gets you to refer to the parent game object. Oh, sorry, not parent game object. The game object that's holding the component. This is very useful because if you want to traverse around the hierarchy without using your mouse, say if you wanted to use a script to make something, then you'd simply call the game object and perform operations on that game object. game objects usually control the size, scale, stuff like that of game objects. So if you want to shrink or expand a game object, an object of which you have a reference that's not a game object, you just call it dot game object. And then you go like dot position or something. Dot scale dot x equals something bigger than 1, and then you could like Gigantamax that object. Okay, but back on topic. In C, so using this, whatever this thing is, the game object of the hit collider, get a component of type card hand script. So this is probably a type that you're unfamiliar with, but the thing is, in Unity, the types of script is the name of the script. So if you want to get a component card hand script, that basically means we're just looking for a script that's attached on the game object called card hand script. Oh, and as you're wondering, yes, it's also case sensitive. There's also these brackets here. Now, some methods don't have brackets, some methods do. Oh, methods and functions are used interchangeably here, but I'm pretty sure some more knowledgeable coder would get into the real nitty-gritty and like lecture me on this. But for now, just treat methods and functions as basically very similar for now. Alright, so getComponent is a function that you have to call round brackets in. This doesn't need round brackets. It's because it's actually a shorthand for one that does have round brackets. And actually, this itself is a shorthand for something else, but that's beside the point. Okay, so we have a card hand script. That means we access the script inside the game object that holds the hit collider. Okay, now onto this last statement. So now that we have a script, we want to get the info of a variable called rand index, which is the final thing that we're looking for. So the whole point of this entire sentence is to get this rand index variable. So that was a pretty long-winded explanation of basically saying, in the hit collider, we access the game object. In this game object, we want to get the component card hand script, which is the script that we attached onto the game object. And in this card hand script, we want to get a variable, rand index. This is how you access variables and scripts, as well as like basically anything else. I mentioned earlier that I'll talk about functions later on, and now I'll talk about it. So functions, they're basically the bread and butter of coding. A bit more complex than variable types and conditionals, but they're very useful in Unity. In fact, you'll probably use it in like a giant majority of all the codes, like 80% or so. In this example, GameObject.find GameObjects of tag. This lets you find a card in the game. So in our tutorial game, some cards, game objects are tagged .card. This finds those game objects and returns it to us. So we could do some operation or read something or, set a value. Functions usually take some or no input. This one takes a string. This one doesn't take any input. And the function does some magic somewhere else. If it's a Unity function, yeah, you probably need to dive into some pretty complex code to understand like the inner workings, but you don't need to. But for functions to create yourself, they actually help a lot for splitting apart complexity. So okay, I'll switch over to the scripts. In this scripts here, that GameObject dot that hitCollider.GameObject.getComponent dot card hand script basically says that if I move over to this right scene gameplay, Save. Hold up, I think it's this one. Well, yeah, and this, no, that's not it. Oops. Hold up. I boot up Visual Studio. Okay. The line specifically that we were mentioning earlier was in Game Manager script. So specifically this line over here. So what this does is, well, you can see there's functions on both sides of the line here. Sorry for the small window, but basically on the left side you want to get the component card barcode. Okay, so we want to assign something into the card barcode from an object called empty hand. And as we mentioned earlier, we assign the rand index into it. If you're a bit confused as to what these giant chains of functions mean, just look at the last, assuming you've named it properly, look at the last couple of functions to understand what's really happening here. So we want to get a rand index from a script that's a part of a game object, and we want to attach it to the card barcode variable in the card script. We use this to pass around values inside the games, so that you could say transfer a score to, I don't know, leaderboard or something. Another example of a function, instantiate, very basic Unity function, basically creates an object, and as mentioned here, by getting an example of original or prefab, which is basically a pre-made object, and then the position to spawn it, and then the rotation. That basically assigns it into a new game object we create. This sentence over here basically says, create an object and assign it to a new game object that we create. This is how people usually generate new game objects using the instantiate function. But this is a good example of a function taking in multiple inputs, and then, yeah. Okay, I'll go back to the slides and go over the common mistakes that people do when coding. Okay. Sorry for the winded way I'm doing this, but I assure you it'll be worth it. Common mistakes. Now you use the debugger to pop up debug messages, and they help you work through any issues in the code. In this case, oh look, there's no semicolon here. Semicolon expected. Incomplete lines. One of the most common errors by newbie programmers, and even some veterans too, especially as stuff gets more complex, like in this. Where's the missing semicolon? If you have a keen eye, you should see that's probably this red squiggly line. But of course, this isn't even that complex at all. In some files I've seen there's like thousands of lines of code, and you try to find a single missing semicolon. Well, if it went for a coding environment like Visual Studio, or VS Code, or Emacs, or anything, then you have a very difficult time finding it. The other type of common mistakes, which we've seen earlier, missing or wrong type conversion. You see here, a vector free is basically a structure of free floats. So basically you create a new one using a function with free inputs. Well, it may not look like a function, but this is called a constructor. which means it constructs a structure called vector free. No, sorry. It constructs a struct of type vector free, and it takes in free inputs to determine the free directions of a vector free. In this case, a vector free is actually forward, backwards, top, down, front, right, stuff like that. X, Y, and Z. It takes in free floats, but since we didn't put in the if here, it means that it's come up with a conversion. What's called double to float, cannot convert type from double to float error, and the compiler doesn't like that. So make sure you put in if, or basically just make the types agree. Basically, rechecking type assignment or function input outputs. Yep, very important. Another big oof for most newbies is missing assignments. No errors is very, very annoying. Honestly, they're probably the most annoying out of all of them, because the errors might not actually lead you to the correct place of the origin, the error origin. So say script 67. You go to a line. Oh, this seems to be all right to me. But the fact is, it's actually using a no value, which was called way earlier in the code. Like, it could be like line 30 even, or line like 1. Missing assignments or no errors is very, very notorious and causes a lot of headaches. So you have to use debug.log to go up the chain, essentially. So you first try to debug.log the thing that caused the error, and then whatever created that object, you should debug.log too. And if that is also no, you go back up the chain. What caused the, or what created or assigned that value, you debug.log that name of that game object, and so on and so forth until you find the origin. Now, no errors could be handled by using no error handling. What you do is, if a value that you obtain from externally, such as a picture pixel, you say, oh, if it's null, debug message, oh, this value is null. Instead of crashing the compiler, you get a neat little debug message saying, there's an error here, you should probably check into it. Okay. Other mistakes, these ones don't throw up any compiler errors, but they're still kind of a headache sometimes, and for big projects all the time. But if you just started, just ignore it. Just first make something that works first of all. Only after you've made something that works should you worry about these kind of things. For example, typos. Everyone makes typos, kind of inevitable. Sometimes they don't throw out errors, and if they don't, then oof. But yeah, if you so much as make a smaller case letter of something that should be uppercase, that could cause an unseen error and lead to hours of frustration. So do be careful once you've gotten into the high end or with more stakes on the line. Typos could be a big issue. Unclear commenting, variable names. Yep, this ties in with the inconsistent syntax, and that the problems usually show up if you're working in a team. Different people have different syntax, different people have different commenting styles, variable naming, stuff like that. So in order to make things as clear to each other as possible, make variable names understandable and easy to read. And last but not least, spaghetti code. It's when code is so complicated, so convoluted, that you don't actually follow through, and then you or someone else just doesn't understand it. Once you get into, say, part 3 assignments, spaghetti code would definitely lose you some marks in the clean formatting points. Okay. Now I'll quickly look at the game after this, but before I do, some stuff if you're a skilled coder and you don't have much time for the rest of the stream. If you want to learn more, the execution order which I mentioned in the other PowerPoint. They're good for if you want to do physics stuff. There's another type of update event function. Update function basically means that this changes every frame of the game. There's this other type of update function called fixed update, which lets you run in real time. So it stays the same throughout different build specs of a computer, and it lets you do things like racing or fighting games accurately without lag slowing down your game or giving you an unfair advantage. There's also coroutines, which is good for timers. Here's one example in a tutorial game. They're very useful if alerts, time-based goals, milestones, stuff like that. There's also finite state machines. You'll probably learn this if you're doing computer systems or mechatronics or software. They're pretty critical for most decent sized games, and they let you control things in order. So once A happens, go to B. Once B happens, go to C. And if condition is met, go back to A again, and so on and so forth. These two links over here, very useful for learning. If you're not sure of a function, you could Google it, and they'll probably lead you to a function that comes up in one of these two places. Alright, so there's the thanks here. Okay, that's the last side of the slide, so I'll go back to the Unity. Okay, since we don't have much time left, I'll just quickly go over the game. This is the tutorial game, thanks to my friend Josh, one of my fellow XX, who made this game over the mid-semester break. So basically, this game is figure out the rule of the dealer with the cards in your hand, marked in red. You choose a card. If it's correct, it pops up on top. If it's wrong, it doesn't pop up, and a warning says this does not fit the rule. You could play as many cards as you want, and once you have a good idea of once you have a good idea of what the rule is, which is seen by the top row, there's a pattern that you have to identify. Just click describe and then pick from the choices the buttons that are shown. And if you choose right, this is how you win Eleusis. Don't ask me how that name came to be. My friend Josh would tell you. Alright, start. Let's see here. Once if I click 5. Oh, that's correct. 8. Okay, it seems to be all blacks now. Up. Okay, yep. Pretty sure that this is, what do you know, all black. Ta-da. Alright, this is an example of a tutorial game we made. I'm pretty sure there's an updated version on the drive right now, so you could go check into that if you want. But otherwise, have a good, I don't know, stay at home, I guess. Have fun making games.